Yeah. So today we are going to discuss about the flip flops here. Okay. So generally, so what we discussed about flip flops in the last classes here is we have edge triggered and we have level triggering. So triggering is application of input which will change the state of the circuit. Okay, and we have level triggered circuits and we have edge triggered circuits. The latches what we discussed earlier is a level triggered, and the flip flops what we are going to discuss right now is edge triggered. They are edge triggered. Okay, so you can see this, these are the pulses here. Okay, so coming to the pulses here, so this is the pulses, and we have two levels here, the positive edge response and the negative edge response. So few flip flops are responsive, like they are responsive to the positive edge, and there are other flip flops they may be responsive to the negative edge. So positive edge is nothing but, so positive, that like 1 to 0. So 0 to 1 is a positive edge and 1 to 0 is a negative edge.
Negative.
Yeah. So the sensitive, I mean, these flip flops will be edge sensitive here. So they may be positive edge sensitive or negative edge sensitive. I mean, their state will be changed from one state to another state, So on application of this input. So what is the meaning of this state here? So earlier what we have seen, so I have given an example of this one, like earlier what we have checked there. So 0 0 is a state, 0 1 is a state, and 1 0 and 1 1. Okay, so the output response to this state, okay, is known as change. So we discussed like there is no change in the state. Okay, and I said that this level is 0. Okay, I said that output is 1, or I'll say that we have the forbidden state. So there is no change in the state. I mean, what the meaning of this is, the no change in the sense it will remain in the same state on application of input. Okay, or it will go to the next state, like next state is 0, or if I say the next state is 1. Okay, or I say the next state is the complement of the previous state. Okay, so that is the meaning of state here. So that the state changes are decided by this inputs here. So what are the inputs here, whether it is a positive input or the negative input? Okay, so you'll be having these positive inputs or the negative inputs here. Okay, and coming to this edge trigger flip flops. Okay, and we'll see about the various flip flops available here. So the circuits, we'll see the circuits. So we'll be having four flip flops here: the SR flip flop, JK flip flop. Okay, and we'll be having D flip flop, and we'll be having a T flip flop. We'll see the circuits for these four flip flops, and we'll do the analysis of these four flip flops here. Okay, so the first one is JK. Sorry, so the first one is SR flip flop. Take down this diagram. Take down this diagram. This is SR flip flop. We'll be applying the clock here. Instead of enable signal, we'll be applying the clock in case of this flip flops here. Okay, so we'll be applying the clock in case of the flip flops. Whereas latches don't have any clocks. So we have seen that. So just only the application of input will be there. So we don't have any clock in case of the latches there. So here we'll be having some latches here. Sorry, we'll be having some clock here. Okay, so the clock signal is applied instead of the enable signal. Okay, so take down this diagram. So we'll see the analysis part of this.
Yeah, sir.
Okay, so done, right? So we have to take the four cases here. S is equal to 0, R is equal to 0. Okay, and S is equal to 1, R is equal to 0. S is equal to 0, R is equal to 1, and S is equal to 1, and R is equal to 1. So we'll check these four cases with this. Okay, so with the help of these four cases, we'll see. So what is the property of this flip flop? So the main things what we are going to discuss with this flip flop is, so we'll see the truth table first. Okay, afterwards from the truth table with the help of K maps, we'll derive some equation, characteristic equation. Okay, the truth tables and characteristic equations are what we are going to see about these 4 flip flops. And we had to remember that for your for your entire BTech, or if you are going to a core job or any kind of job, so these properties are very important. Okay, so you have to know, whatever the operation I'm letting you know, so is explanation of the what is happening inside, but what you have to remember at the end of the day is you have to remember the characteristic table, that is the truth table, and the equation, the characteristic equation, so which is the equation obtained after the simplification of the truth table there. Okay, so we'll see that. So we'll see the first case here. So we'll see the first case. Okay, so we'll see the first case, like when we'll start with s is equal to 0 and r is equal to 0. S is equal to 0 and r is equal to 0. Okay, and meanwhile what we'll do here is, so we'll assume that, so check here, so we'll be having qn and this is qn bar. Okay, and if I want the output, so what I'll do here is, wait a minute, so q of n plus 1 is the next state. Okay, so that is the output. Q bar of n plus 1 is the output here, and if I want the present state, that is represented by q of n. Okay, it is represented by q of n, and the complement is represented by q bar of n here. So getting my point here, so q of n plus 1 is the next state, on application of the input clock. Okay, and the present state, so that is qn, and we'll get the next stage here. Clear? Yes or no? It here the q of n plus 1 will be the next state. So how will we get the next state? So we'll apply the input here, an application of input, the clock signal will give the clock signal, and the present stage will give the next stage. Okay, so n plus 1 stands for the next state here. Yes or no?
Yes, sir.
Okay,
Yes, sir.
so understand this, because these concepts are very important. So when you are doing the analysis part, so just don't simply say yes or no. Okay, just understand these concepts here, the q of n plus 1 and q bar of, you don't have these analysis part in your textbook. Okay, so analysis part, you don't find this analysis part in your textbook. What I mean to say here is, like you don't find them in a better way. So what you have to see here is, you have to see the analysis part here. Okay, so analysis part కొంచెం మీరు అర్థం చేసుకోవాలి. Analysis part అర్థమైతే you will know how the truth table we got here. Okay, so this is qn is nothing but the present state here. Okay, before the application of input, so before the application of input to the circuit here, so we will be having the present stage, and after application of inputs and present stage, we'll get the next stage, we'll get the next stage. So that is the logic here. So before application of input, so the outputs what we got are the present stage. Okay, and the present stage plus the inputs plus clock will give the next stage. Clear? Hello, excuse me.
Yeah, sir.
So please respond, right? So because I told you this is very important, these topics are very important. Okay, and you have to understand them very clearly. Okay, so when s is equal to 0 and r is equal to 0 and clock is given, so I'll put a clock as 1 here. Okay, and so we'll see. Okay, so s is equal to 0, r is equal to 0 and clock is equal to 1. The property of NAND gate is, so when any one of the inputs is 0, when any one of the inputs is 0, the output is equal to 1. Okay, when any one of the inputs is 0, the output is equal to 1.
1.
Okay, and so q of n plus 1 will be the next state. Okay, so q of n plus 1 will be the next state. So meanwhile, so what we'll get here is, okay, so what is q of n plus 1? So this is q of q and q bar. Okay, so q of n plus 1 will be the next state, So q of q bar of n plus 1 will be equal to, so you can see here, okay, so this is given to the this flip flop and this is given to the this flip flop. So the meaning of this is q of n plus 1 will be the summation of 1 into it's not q of n plus 1 into qn here. Okay, so 1 into qn, and this is 1 into qn whole bar, because this is the NAND gate, so it is 1 into qn whole bar is given to this one, and here so 1 into qn bar whole bar, I mean 1 into qn bar, okay, so 1 into qn bar, so will be given to this NAND gate. So getting my point here.
Yes, sir.
Okay, so q of n plus 1 is nothing but, so we have to multiply this. Already we have some outputs, right? So we have some outputs like qn and qn bar. Okay, so q of n plus 1 is this AND gate, so this AND gate is 1 2 and this is 3 and this is 4, right? So output of third AND gate is so 1 into qn bar, okay, and this one is like output of fourth NAND gate is so 1 into qn, 1 into qn is given to the fourth NAND gate here. So are you clear about this?
Yeah, sir.
Okay, so what we had to do here is, wait a minute. Okay, so you forget about this q of n plus 1. Okay, and q of n plus 1. So what we'll be having, what we got here, it is q and q bar anukundam. So generally, so what you think is like q, this is q and this is q bar. Okay, so this will be like output of this NAND gate will be like, so this one. So this is given to this one and this is given to this one. So 1 into q bar is the input to this third NAND gate. Okay, and the output will be like this. So AND gate is like 1 into q bar is 1 into q bar, whereas in case of NAND gate is an inversion of AND gate. So 1 into q bar whole bar. Okay, so that will become, so 1 into q bar is q bar here. So q bar whole bar is equal to q. So q bar whole bar is equal to q. So that will be the output of this third NAND gate. Clear? Okay, and this one, so 1 into q, so 1 into q, so output of this NAND gate will be 1 into q whole bar. Okay, so that will be equal to q bar. Okay, so what we got is here is, so here we got a q bar and here we got a q, so there is no change in the state here. So what are the values here? Those values are the previous values only. Yes or no?
Yes, sir.
Yes. Okay, so you remember this. Okay, so we'll see the analysis part here.
Sir, some are waiting, sir.
Okay, so we'll see the analysis part here. So SR flip flop. Okay, so first case is like S is equal to 0 and R is equal to 0 and clock is equal to 1. Okay, so when if I assume this as 0 0 1, one of the inputs is 0, output is 1, so 1 into q bar. Okay, and this is 1 into q, and this is given as the output here, so 1 into, so q bar whole bar, so we'll give a value of q only. Okay, and 1 into q, so 1 into q whole bar will be equal to q bar. Okay, so the new values like next state values q plus 1 will be equal to q, and q of n plus 1 bar is equal to q bar. I mean, there is no change in the states here. So whatever the values that are present in the earlier cases only, so we are getting the same values. So there is no change in the state here. The meaning of this is there is no change in the state. Okay, so this is the analysis part here. So we'll be having 4 gates here. So gate 1. So this is 1, 2, 3, and 4 here. Okay. Okay, and coming to these cases here, so what we can do here is, so gate 1 output, so I'll call it as G1. Okay, so G1 is equal to, because one of the inputs is like 0, G1 output is 1. Yes or no? Okay, so one of the inputs is 0, the output is property of NAND gate, the output is 1. Okay, and coming to this G3, so G3 output, so what we'll get here is, so 1 into Q bar,
Q bar.
so that is Q bar whole bar. Okay, so 1 into Q bar whole bar, that will be the output here. So input is 1 into Q bar, so NAND gate is nothing but, so A into B whole bar, so 1 into Q bar whole bar. Okay, and G4 is, so 1 into Q whole bar.
Whole bar.
Okay, so what is that we get here? So for G3, so we get output of G3 is Q, output of G4 is Q bar.
Q bar.
Okay, so G3 is nothing but it is the next state here. So next state is like Q of N plus 1 or P plus 1, whatever the values. Next state is nothing but N plus 1 is equal to Q, or I can say it as Qn also. Okay, so Qn is nothing but, so N plus 1 is the previous state, Q of N plus 1 is the next state. Okay, so in a similar way, so Q bar of N plus 1 is equal to, it's Q bar of N. Okay, so there is no change in the state. So when S is equal to 0 and R is equal to 0, so there is no change in the state. Clear about this?
Okay, sir.
Okay, so this is the thing here. So this is this is equal to 0 and R is equal to 0 case here, and clock is equal to 1. Okay, next we have to check the next case. So S is equal to 0 and R is equal to 1. Okay, we'll check the next case. S is equal to 0 and R is equal to 1. Okay, so when S is equal to 0 and R is equal to 1 and clock is equal to 1 here. Okay, consider this case here. Okay, so S is equal to 0, R is equal to 1 and clock is equal to 1. So this is the first gate, second gate, so third gate and fourth gate. For first gate is 0, 1, one of the inputs is 0, the output is 1. So both are 1, the output is 0 here. Okay, and so when one of the inputs of NAND gate is 0, so what is output? When one of the inputs of NAND gate is 0, what is output?
1, sir.
So it is equal to 1. So Q bar is 1. When Q bar is 1, automatically Q will be equal to 0. Okay, when Q bar is 1, automatically Q will be equal to 0 here. So next state is like Q of N plus 1 is equal to 0 and Q bar of N plus 1 is equal to 1. Is equal to 1 here. Clear?
Yeah, sir.
Okay, so this is simple. Okay, when S is equal to 0, R is equal to
R is equal to 1.
1. So this is called as reset state. Reset state ante output manaki 1 ravali. So output 0 ravali. So set state ante output 1 ravali. Okay, so here so gate 1 output is equal to 1. Okay, and gate 2 output is equal to 0 and gate 3 So we'll talk about gate 4 first. So instead of gate 3, we'll talk about gate 4 because gate 4, one of the inputs is 0. So hence gate 4 output is equal to
1.
1 here. So when it is 1, automatically gate 3 will be equal to 0.
0.
Okay. This is q of n plus 1. That is q of n plus 1. So the next state here. Okay. So n plus 1. Okay. So this is q of n plus 1 and this is q bar of n plus 1. Q bar of n plus 1. Okay. So when this is applied, so what is applied here? So we apply, okay, so when we apply 0 1, s is equal to 0 and r is equal to 1. Okay. So when we apply s is equal to 0 and r is equal to 1, so we'll get output of q is equal to 0 and q bar is equal to 1. So instead of that, so we'll say that q is equal to 0. So q is equal to 0 means it is a reset state. Okay, it is nothing but a reset state. Okay.
Yes, sir.
Okay. So next we'll take the next case here. So we'll take the next case. So we'll take the next case of s is equal to 1 and r is equal to 0. Okay. So s is equal to 1 and r is equal to 0. That will be the next case. So when s is equal to 1 and r is equal to 0. Okay, and clock is equal to 1. Okay. So what happens here? So this is 1, clock is 1 and this is 0. So obviously the output of first AND gate is 0, output of second AND gate is 1 here. So when one of the inputs of AND gate is 0, the output is equal to 1 here. The output is equal to 1. So when this is 1, automatically this will be equal to 0. Okay, this is 1, this is equal to 0. So this is nothing but q of n plus 1 is equal to 1 here. So this is called as set state. Okay, this is called as the set state here. Clear?
Yes, sir.
Okay, so this is the case here. So G1 is equal to 0, D2 is equal to 1 and G3 is one of the inputs is 0. So G3 is equal to 1, output is 1 and because G3 is 1 and G4 is equal to 0 here.
0.
Okay. So this is q of n plus 1 and this is q bar of n plus 1. This is called as set state. When s is equal to 1 and r is equal to 0, it is a set state. Okay?
Okay, sir.
Okay. Next one. When s is equal to 1 and r is equal to 1. So it is an indeterminate state. Okay. So what happens here is, so it is an indeterminate state when s is equal to 1 and r is equal to 1. So what happens when s is equal to 1 and r is equal to 1? S is equal to 1, r is equal to 1 and clock is equal to 1. So when both are 1, so these are equal to 0, 0. When one of the inputs of NAND gate is 1, so this is 1 and this also equal to 1, which is not possible. So hence it is a forbidden state. Okay.
Yes, sir.
Okay, so these are the 4 cases here. So we'll see the truth table of this. Okay, so we'll see the truth table. So we have to remember the truth table. One is the elaborated one, other one is the normal shortcut here. Okay, so we have to check the elaborated ones and the normal shortcut truth tables here. Okay.
Yes, sir.
Okay, so we'll see that. So we'll see S R, and this is Q of n will be the present state. So what I told you earlier is like the Q of n, so will be the present state. Okay, these present states plus inputs will decide the next state. So that is equal to Q of n plus 1. So we'll not talk about Q bar of n plus 1. Just we'll talk about only Q of n plus 1 here. Okay. Right, S is equal to 0 and R is equal to 0, and Q of n is don't care whether it is 0 or 1. So previous cases 0 or 1, so we are least bothered about that. Okay, so when these are equal to 0 0, so what happens when S is equal to 0 and R is equal to 0? What we got earlier? Same with So what are the values of Q of n plus 1 and Q of n? Q bar of n plus 1.
Q and Q bar, sir.
Qn and Qn bar.
Q and Q bar, sir.
Yeah, we'll
Yes,
get a
sir.
Q. Okay, so the meaning of this is, so when S is equal to 0, R is equal to 0, if Qn is 0, I'll get a 0. Okay, when S is equal to 0, R is equal to 0, when Qn is 1, I'll get a 1 here. So that is the meaning of that. Clear?
Yes, sir.
Okay.
Yeah, sir.
Yeah, sir.
So this is the elaborated truth table here. Next, S is equal to 0 and R is equal to 1, irrespective of the value of Q of n. So what is output I'll get here? So Q value ఏమొచ్చింది? Next state value.
Sir.
Z-
Emma? So what is that? ఏమొచ్చింది? S is equal to 0, R is equal to 1
0,
వచ్చినప్పుడు
sir.
what is 0? So we got a 0.
Q equals to 0, Q bar equals to 1.
Yeah. So main thing is Q. We'll talk about Q of n plus 1. That is next stage. So bar is like automatically the complement of this one. Okay. Yeah. So this is what we got here. So the meaning of this is 0 1. If present state is 0, it will be a 0. 0 1. If present state is 1, it will also be a 0. So that is the elaboration of this. Okay.
Yes, sir. Yes, sir.
Yeah. So next case is like 1 0. So 1 0 irrespective of Q of n plus 1. So what is output I got here? What is output I'll get
1.
here?
1, sir.
1, sir.
1. Yeah. And 1 1 irrespective of this one, I'll get a forbidden state. So forbidden state or indeterminate state. Okay. So 1 1 it's not possible. Clear?
Yes, sir. Yeah, sir.
Yeah, sir.
Okay. So this is the truth table. Okay. In short, if I want, in short, I'll remove this Q of n. Okay. So what is this? Is what you have to remember every time. So SR 0 0. Okay. So SR 0 0 and Q of n plus 1. So that will be the output. That is how Q of n plus 1 will be the output here. Okay. So if it is like 0 0, so I'll get a Q of n. Okay. If it is 0 1, I'll get a 0. If it is 1 0, I'll get a 1. If it is 1 1, it is an indeterminate state or the forbidden state. So this is what you have to remember in short. So for K-map purpose, I'll let you know. So K-map purpose ki దీన్ని elaborate చేస్తాం. Clear?
Yeah, sir.
Okay. So take this take this truth table and we'll see the elaborated truth table of this one. Right. So why I'm explaining, because you know, so you have to get the idea of like why we got these values, because you need the explanation of those, because you have to understand so why we got those values. Clear?
Yes, sir.
Yes, sir.
So next we'll check the values of, I need an equation for Q of n plus 1. I need an equation for Q of n plus 1. For this I'll take the help of this truth table. Okay. So we'll see that. So meanwhile, remember this one, but we'll elaborate this one. Okay, so the elaboration will be like this. So S R Q of n and Q of n plus 1. So instead of don't care, so what I'll do here is I'll mark it as a 0 1. Like I mean, once I'll take 0, and other time I'll be taking so 1 here. Okay, so I'll be taking a 1. So 0 0. So first I will take a 0. So what is Q of n plus 1? So elaborate this one. What is Q of n plus 1? So what is Q of n plus 1? Faster.
Qn.
So Qn, what is the value of Qn I got? I mean, I'm elaborating this one. Instead of using don't care, I'll be using two cases here. So don't care until 0 oksari, 1 oksari.
Okay,
0, sir.
Yeah, it says 0. When SR is equal to 0 0, when Q of n is 1, so what is the value?
Q of n, sir.
So Q of what is Q of n?
1, sir.
So it's a 1.
1, sir.
Okay. So next 0 1 0. So what is output?
0, sir.
0, sir.
0 1 1.
1, sir.
1, sir.
How?
0, sir.
0, sir.
This is that is what I'm telling you. So this is 0 1, don't care, right? So don't care, 0 oksari use చేసాను, 1 oksari use చేసాను, but the values of S and R are not changed. The values of S and R, irrespective of the values of Qn, the values of S and R are equal to 0 1. So when they are 0 1, obviously the output is equal to 0.
Yes, sir.
Okay. So apply some common sense here. Okay. And what is the next one? So 1 0 1 0 0. What is output?
1, sir.
1, sir.
1. So 1 0 1
1, sir.
1. Yeah, 1 0 1. It's a 1 because you know 1 0 don't Q of n is don't care. So if the value of Q of n is 0 or if the value of Q of n is 1, so we'll get the values of 1 only, 1 output only. Okay. And the last case is like 1 1 0 and 1 1 1. Okay. For the forbidden state, and it will be a don't care. So we'll I mean we don't get any kind of output here. For simplification, what we'll be using here is just we'll put a don't care state. Okay, we'll put a don't care. Clear?
Yeah,
Yes,
sir.
sir.
Yeah, sir.
Okay. So this is the elaborated truth table, and I need a this one. I need the K-map for this. I need equation for Q of n plus 1. Okay, I need equation for Q of n plus 1. I think it's not here. Yeah. So wait a minute. Okay, this is the elaborated truth table. Okay, this is the elaborated truth table. So you can take this truth table. So this is what I got here, and this is S and RQN. So we'll draw a K-map for S and RQN. Okay, so wait a minute. Right. So elaborated truth table is nothing but for this is S here, and this is R and Qn. Okay, so this will represent S here, and this will represent R and Qn here. Okay, so you can check here, and this is 0 0 0 for S is equal to R is equal to 0, Qn is 0. So what we need is ones only. So ones and don't case. But 0 0 1 it's a 1. Okay, for 1 0 0, so 1 0 0. So 1 0 0 it's a 1. Okay, for 1 1 0 and 1 1 1 it's a don't care. So for 1 1 0 it's a don't care, and for 1 1 it's a 1 here. Clear? Okay. So what I can check here is, so what is correct? Is it correct or wrong? So 0 0 1, yeah, fine. And
Go 1 in this, sir.
yeah, so 1 0 1. So where is 1 0 1? This is 1 and 0 1. This is a 1 here. Okay. So this will be, the grouping will be like this. So what is this one here? So what is this one?
0 1.
So this is
R
0
Q
1. This is
R
R
bar
bar
Q bar N.
Q bar N.
Qn. Okay, and I can take this 4 here. Okay, I can take, what is this one here? This is S.
Yes, sir.
Okay, so this is the equation here. So Q of n plus 1 for a flip-flop equation. The flip-flop equation for S of flip-flop is like S plus R bar Qn. Okay, S plus R bar Qn. It's clear?
Yes, sir.
Okay. Yeah. This is the equation of SR flip-flop, and this is the elaborated truth table of SR flip-flop. Okay, and this is the normal truth table. Like this is the normal truth table, and if I eliminate this one, if I eliminate the value of Qn, okay, so this is the simplest truth table here. So this one you have to remember for sure. Okay. So you're clear about this, right?
Yes, sir.
Okay. So next we'll see the next flip-flop. Okay. Next we'll see the next flip-flop, that is D flip-flop. Right. This is the D flip-flop here. So we'll analyze this part here. The truth table is like, so we'll take the first case here. So this is D flip-flop. So take the first case. So D is equal to 0. And clock is equal to 1. So this is the first case here. Okay. So D is equal to 0 and clock is equal to 1. Okay. And so check the case here. So we'll take G1. So gate 1 output. So gate 2 output. So gate 3 and gate 4. Okay. This is gate 1, gate 2, gate 3 and gate 4. Okay. So we'll take the case here. So the first case is like D is equal to 0. This is gate 1, this is gate 2 and clock is equal to 1. Okay. When D is equal to 0, so here it will get a 1 here. Okay. When one of the inputs of NAND gate is 0, the output is equal to 1. So G1 is 1 and G2 is equal to 0. Okay. So G1 is 1 and G2 is equal to 0.
0.
Yes, sir. Okay. And now the value of G2. So this is 0, right? So this is a 0. When one of the inputs of NAND gate is 0, so what is the output here? So output of G4 is equal to 1. Okay.
1.
And I'll get a G3 as 0 here.
0.
Okay. I'll get a G3 as 0. Okay. So that is the case here. Okay, so this is G3 will be, when G4 is 1 here, automatically G3 value is equal to 0 here. Okay, automatically the value of G3 is equal to 0. Yes or no?
Yes, sir.
Yes, sir.
So that is the case here. So when D is equal to 0, so this is G3 is nothing but Q of n plus 1. G3 is nothing but Q of n plus 1. Okay. And this is nothing but Q bar of n plus 1. is nothing but q bar of n plus 1. Okay,
Yes, sir.
this is simple, right? So this gate is simple. One of the inputs is 0, the output is equal to 1 here, so hence q of is this 0. So when d is equal to 0, q of n plus 1 is 0. When d is equal to 0, q of n plus 1 is 0.
0.
Okay, so that is the case here. Right, we'll take the next case here. So please note down this. So G3 is equal to 0 and G4 is equal to 1 here. So this G3 is nothing but Q of n plus 1 is 0 here. So Q of n plus 1 is equal to 0 and Q bar of n plus 1 is equal to 1 here. Okay?
Yes, sir.
Okay.
Yes, sir.
So next is 1 minute. So 1 minute. Yeah. So next, same case. So D is equal to 1 and clock is equal to 1. So check the case here. So this is D1. So this is 0. So clock is 1. So when both the inputs are 1 here, so this is 0 and this is a 1. Okay. So when one of the inputs of NAND gate is 0, the output of the third NAND gate will be equal to 1 here. So Q will be 1 and Q bar will be equal to 0. So hence Q of n plus 1 is equal to Q of n plus 1 is equal to 1 here. Okay. So G1 is 0. So G2 is 1. So G3 is 1. This is Q of n plus 1. Okay. And G4 is Q bar of n plus 1. Okay. So this is quite simple. So what are the inputs we give? That will be the value of Q of n plus 1. Okay. That will be the value of the Q of n plus 1. Okay.
Yes, sir.
Yes, sir.
Yeah. So next, so we'll see the truth table of this. So we'll see the truth table of this one here. Okay. So here the truth table is, so D is the input and Q of n will be the present state here and Q of n plus 1. Okay. So Q of n plus 1. Okay. So D will be equal to 0. So irrespective of the value of Q of n. So when D is 0, so what we got? So we didn't get any values of Q of n alage em raledu. So we got a 0. Yes or no?
Yes, sir.
So when D is equal to 1, with respect to the value of present state, the value of Q of 1 is 1 here. Okay?
Yeah, sir.
Okay, so this is the truth table. If I need the elaborated truth table here, okay, so if I need the elaborated truth table, so what I can draw here, so like D, Q of n, and Q of n plus 1. Okay, so 0, 0,
0.
and 0, 1,
1.
and also 1, 0,
0.
and
1.
1. Okay, so Q of n plus 1 is 0 when D is 0. So Q of n plus 1 is 0 for
0.
0, and Q of n plus 1
Yep.
is 1 for this
One.
and 1 for
One.
this. If I go for a K map, okay, so if I use a K map here, it's like so 1, 2, 3, 4, and this is D, and this is Q of n. Okay, so it's like 0, 1, 2, 3. For 2, 3, it's equal to 1 here. So this is 0, this is 1. So this is Q of n plus 1 is equal to these two values. So what are these two values group here? We'll get a D here.
D.
Okay, so we'll get a D. Clear?
Okay, sir.
Okay, so Q of n plus 1 is D. So remember this. This is very important equations and two tables. So in short, the two table will be like this. So Q of n plus 1. So 0, 0, so 1 and 1. Clear?
Yes, sir.
Yes, sir.
Yeah. So this is the case here for a D flip flop. Okay. This is the case of a D flip flop. Next we'll see JK flip flop. Okay. So these things are very important, right? Remember that these two tables equations are very, very important. Right. So we'll go for a JK flip flop. Take note of this diagram.
Done, sir.
Fine. Yeah. So here also we'll take the cases here. This is a JK flip flop. So just like set reset flip flop, so we'll be having JK flip flop. So S stands for, I mean, S is like J and R is like K. So set reset flip flop on SR flip flop. So here we don't have any names here. It's just a JK flip flop.
Okay, sir.
Yeah. So fine. So JK flip flop. So we'll take J value is equal to 0 and K value is equal to 0 and clock is equal to 1. Okay, so the main advantage of JK flip flop is, so here what we had in the forbidden state, so that forbidden state can be eliminated. So in case of SR flip flop, we had a forbidden state, so that forbidden state can be eliminated with the help of this JK flip flop. Okay, so that
Yes, sir.
state is zero, so the forbidden state, so that forbidden state can be eliminated with the help of this JK flip flop here. Clear. So we'll check the first case here. J is 0 and K is 0. Clock is equal to 1. Okay. So this is the first case. So J is equal to 0. K is equal to 0 and clock is equal to 1. Okay. So when one of the inputs of, you can check here. So G1, this is 1, 2, 3 and 4. Okay, so G1, G2 and G3 and G4. Okay, so 0 1 scheme problem undadu. The main problem lies with this 0 0 and 1 1 ki koncham calculations untai. So that is what you have to understand here. Okay, so G1 is, so when one of the inputs says 0, so the output is equal to 1, and G2 is also equal to 1. So here we got is 1, and here we got a 1. Okay, here we got a 1, and here we got a 1 here. Okay, and you can check here. So this 1 into will get a Qn bar. Okay, and here we'll get a, so 1 into Qn. Okay, the output is 1 into Qn bar whole bar. So what is the value we'll get here? We'll get a value of Qn, and here 1 into Qn whole bar, we'll get a value of Qn bar. Okay, the next state is nothing but Q of n plus 1 is equal to Qn, and Q of n plus 1 bar is equal to Qn bar. Clear? Just like the earlier case. So earlier case in the S of flip flop 0 0 unnappudu, the same case here. Okay, so here what we'll get here is, so 1 into Qn bar whole bar, and here what I'll get here is, so 1 into, so Qn whole bar. So I'll get a value of Qn here, the Q of n plus 1. So G of 3 output and then Q of n plus 1, and here I'll get a value of Q of n plus 1 bar is equal to Qn bar. Clear?
Yes, sir.
Yeah, sir.
Okay, so this is the case with 0 0. So 0 0. So when J is equal to 0 and R is equal to 0, there is no change in the state here. There is no change in the state. So whatever the values we got here, so those values are nothing but those are the values of the previous values, like Q of n and the Q of Qn bar here. So Q of n plus 1 is Qn, means it remains in the previous state only. There is no change in the state here. So whatever the previous states here, so those states will be remain the same here. Okay, so that is the first case here. Okay, and if we take the second case, so please note down this analysis part. Okay, so because those things are in the future when we are listening to any topics, we'll definitely understand it. Okay, next one is, so J is equal to 0 and K is equal to 1. One minute. Yeah. Okay, so J is equal to 0 and K is equal to 1. The first case is fine, and we'll take the second case. So clock is equal to 1. Okay, the clock is equal to 1 here. Okay, so what happens when clock is equal to 1? So when J is equal to 0 and K is equal to, this is 1, this is 2, this is 3, and this is 4 here. Okay, this is 4. Okay, so J is equal to 0, clock is 1, and K is equal to 1 here. Okay, when one of the inputs of, so G1 is equal, one of the inputs of an AND gate is 0, so we'll get a 1. Yes or no?
Yes, sir.
Yeah, sir.
So when both the inputs are 1, so what we get here?
0.
So 1 minute. So both the inputs are 1, but we got this one. So remember this. So you can check here. So check the another input of NAND gate here. This is the third input. So what is this value here? This is Q of n. This is Q bar of n. So third input is like G2. What we'll get here is, so 1 into Q of n whole bar. Okay, so 1 into Q of n whole bar. Are you clear about this?
Yes, sir.
Okay, so don't have any confusion, because this structure is like this. This Q of n 1 into Q of n whole bar. So what is that I'll get here? So I'll get a value of Q of n bar here. Okay, so what I'll get here is, so output of G2 is Q of n bar. Okay.
Okay, sir.
Okay. So now what we have to check here. So 1 minute. Yeah. So now what we have to check here. So check this of third and fourth outputs. So G3 and G4. Okay. So check the value of G4. So what I got in G4. So G4 is one of the inputs is Qn bar. Okay. And I'll get another input as Qn. Okay. So Qn bar into Qn whole bar. Yes or no?
Yeah, sir.
Okay. So what is the output now? What is the output now? So what is G4 output? Qn bar into Qn whole bar. Why so late? So what is A into A bar?
1, sir.
A into A bar, 1.
0, sir.
A into A bar is 0. So 0
0.
whole bar is 1. So
1.
G4 output is equal to 1. So G4 ante Q bar of n plus 1 is 0. So when Q bar of n plus 1 is 0, automatically the value of Q of n plus 1 is equal to 0. Yes or no?
Yeah, sir.
So the follow up now, Leda.
Yeah,
I'll
sir.
definitely
Follow.
ask the questions in this. Definitely I'll ask the questions in this. Okay. So here 1 into Qn bar whole bar, Qn bar, I mean Qn whole bar will be giving the values of Qn bar here. So Qn bar into Qn will give the value of 0, 0 here. So 0 into is given a complement of 0 bar is 1 here. So we got Qn of Q of n plus 1 is equal to 1. So when this is 1, obviously this is equal to 0 here. Okay, so G3 will be equal to 0. So Q of n plus 1 is 0, Q bar of n plus 1 is 1 here. Clear?
Yes, sir.
Okay. Yeah. So the next thing is, so J is equal to, so J is equal to 1. So J is equal to 1 and K is equal to 0 and clock is equal to 1. Okay. So when J is equal to 1, so K is equal to 0, clock is equal to 1. So output of G1, that is gate 1, is equal to, so 1 into, okay, so this is 1 and this is 1 input and this is the third input, that is Qn bar. So 1 into Qn bar whole bar. So what is that I'll get here? I'll get a value of Qn. Yes or no?
Yeah, sir.
Yes, sir.
Okay. So next G2, one of the inputs is 0, one of the inputs is 0, since G2 will be equal to 1. G2 value will be equal to 1 here. Yes or no?
Yes, sir.
Okay. So next G3. Okay. So we have G3 here. So G3, you can check G3 here. So G3, what I got here is I got a value of Qn. Okay. So Qn and this one is Qn bar. Okay. So Qn into Qn bar whole bar. Okay. So what we'll get here is Qn into Qn bar is a
0.
Qn bar is a 0. So 0 bar will be equal to 1. So G3 will be equal to 1 here. So when G3 is 1, so G4 will be equal to, so here already we have a 1. So 1, 1 will get a 0 here. We'll get a 0. Yes or no?
Yes, sir.
Yeah, sir.
Okay. So hence G4 is equal to 0. So Q of n plus 1 is 1 and Q of bar of n plus 1 is 0. So this is the same cases in case of SR flip-flop. We'll go for the last case here. So that is j is equal to 1 and k is equal to 1. So j is equal to 1 and k is equal to 1. Okay, and clock is equal to 1. Okay, and clock is equal to 1 here. Okay, so what happens here is, so check the cases here. So j is 1 and k is 1 and clock is 1. So output of G1 will be equal to, so 1 into Qn bar whole bar, that is equal to Qn. Okay, and G2, so 1 into Qn whole bar, that is equal to Qn bar. So what I got here is, so Qn and Qn bar. Yes or no?
Yeah, sir.
Okay.
Yes, sir.
So now what I do here is, I'll assume some values here. Okay, I assume values for Qn and Qn bar. Okay, I'll assume values for Qn and Qn bar. So what I'll assume here is, I'll assume a value of Qn here. Automatically the value of Qn bar becomes 1 here. So don't take it complicated. Just assume the value for Qn here. So I'll assume the value of Qn is 0. Okay, so Qn is 0 anukuntanu. So when one of the inputs of NAND gate is 0, so what is the output?
1, sir.
I'll get a value of output of 1, and here I'll get a value of 0 here.
0.
Okay, so if I assume 1 here, so Qn is 1 అని assume చేస్తాను and Qn bar is 0 అని assume చేస్తాను. Okay, so then output of fourth NAND gate is equal to 1 here, and this will become 0 here.
Yes.
Yes or no?
Yes, sir.
Okay, so here what happens here is, so Qn 0 అయినప్పుడు 1 వస్తుంది అవుట్పుట్ మనకు, Qn 1 అయినప్పుడు 0 వస్తుంది అవుట్పుట్. Yes or no?
Yes, sir.
Yeah,
Okay,
sir.
the meaning of this is, so G3 will be equal to Qn bar. Okay, so G3, G4 will be equal to, so Qn bar and G4 will be equal to,
QN.
okay, and if this is Qn bar, okay, if G3 is Qn here, obviously G4 will be equal to Qn bar. Okay, so clear? Okay, so what I'm doing here is, so this is the output of first gate and second NAND gate here. So now assume so Qn as 0 here. So when I assume Qn as 0 here, so automatically the Q of n plus 1 is equal to 1. The value of Q of n plus 1 is equal to, sorry, 0 అయినప్పుడు I'm getting value of 1 here. Okay, and if I assume, so Q of n is equal to 1 here, so what is the output I'm getting here? So Q of n plus 1 is obviously equal to 0.
0.
So I'm getting toggle state here. I'm getting the toggle state. So toggle state in the sense, so what are the inputs I'm giving? So I'm getting the complement of that input here. Yes or no? Okay.
Yes, sir.
Just go for a small assumption here. The assumption is like, so what we have to do here is, the assumption is, so Q of n and Q of n bar వస్తుంది ఇక్కడ. సో ఏదో ఒకటి అజ్యూమ్ చేసుకుంటాం, మన Q of n and Q bar f అని అజ్యూమ్ చేసుకుంటే ఏమవుతుందంటే, సో వన్ ఆఫ్ ద ఇన్పుట్స్ ఆఫ్ NAND gate is 0, the output is 1. సో హియర్ Q of n 0 అజ్యూమ్ చేసుకుంటే ఇక్కడ 1 వస్తుంది, అండ్ Q bar of n 0 అజ్యూమ్ చేసుకుంటే ఇక్కడ 1 వస్తుంది, ఇక్కడ 0 వస్తుంది. Yes or no?
Yes, sir.
Yeah, sir.
Okay, so this is the case here. So this is the thing here. So this is what we'll get in case of the JK flip flop. So now we'll draw the truth table now. Okay, so truth table will be like this. So first the elaborated one, JK, Q of N, Q of N plus 1. So you have to tell. So JK 0, 0. So I'll take a don't care of Q of N. Okay, so what is that I'll get here? So tell me the value of what is the first case we discussed? So you're noting down it, right? So మీరు రాసుకుంటారు కదా ఇది. So analysis part అంతా.
QN, sir.
So the value of this one is QN. So very good. Yeah. So 0, 1 and QN is don't care. So what is that I'll get here?
0, sir.
0, sir.
Yeah, very good. So next 1, 0. Don't care.
1, sir.
So I'll
sir.
get a value of 1. And 1, 1. Don't care. So what is the value you'll get here?
Q bar N.
QN.
Qn bar. So that is, yeah, Q bar N. So Qn bar. Okay, the complement of the present state. The complement of the present state there. Okay, so this is the truth table. And if I need an elaborated one, so put a 0 here. Okay, I'll get a 0. Okay, 0, 0, 1. You get a 1. Okay, so here irrespective of the values of the Qn, I'll get a 0. And here irrespective of the values of so 1, 0, 1, I'll get a 1. And the last one is 0. If it is present state is 0, I'll get a 1. Okay. If present state is 1, I'll get a 0 because it is a toggle state of the previous state, right? So Q of N is the previous state. So this is the elaborated one. So draw the K-map for this. So when we draw the K-map for this, okay, so this is the K-map for this. Yeah, so this is 0, 0, 1. It's a 1. 1, 0, 0. It's a 1. So 1, 0, 1. It's a 1. And 1, 1, 0. It's a 1. And then yes or no? Are you there?
Yeah, sir.
Yeah, sir.
So this 2 and this 2. So this 2 will give a value of K bar Qn. Okay, and this 2 will give a value of what is this value here? This is J Q bar N.
K bar, sir.
Huh? K bar N? No, J Q bar N. Okay, so these two columns here. So these two will eliminate K here. So Qn bar. Okay,
Yes.
so J Q bar Qn bar plus K bar Qn. Yes or no?
Yes, sir.
Okay, so this is the equation. So J Q bar plus K bar Q. So far we got this S plus R bar Qn for S of flip flop, and for D flip flop, so Q of N plus 1 will equal to D, and this is for JK. Okay. Yes or no?
Yeah, sir.
Yeah. So these three equations, and we'll be having a truth table. The truth table in a simplified format. So what we get the truth table in the simplified format. So wait a minute. Yeah, simplified format will remove all these Qn values. This truth table you have to remember.
Okay, sir.
Okay, this truth table you have to remember here, and so we'll see the last flip flop now. So JK flip flop is fine, right? So this is the JK flip flop, D flip flop, and SR flip flop we have seen, and we'll see the T flip flop, which is the last one. Okay, so last flip flops, and we'll see the equation for that flip flop, and we'll see the truth table for that, and we'll see the characteristic equation for that. Yeah, so this is T flip flop. So T is equal to 1 and T is equal to 0. So T is equal to 0 and clock is equal to 1. Okay, so for a T flip flop, so what happens here is, so J and K inputs are tied together. You can check here. So for a JK flip flop, so if I tie these two inputs together, so then we'll get a T flip flop. So everything is same here. Okay, so what is the equation for JK flip flop? So what is the equation for JK flip flop? So we got JQN
JQ
plus
bar N.
QN bar plus K bar
K bar QN.
QN. Okay, so if I replace this J and K with T, so it is like T QN bar plus T bar QN. Okay, there is nothing but XOR gate, right? So T XOR of QN. So that will be the equation of T flip flop here. So without any further complications, we can do this, but we can do this with the analysis part also. Okay, so T Q bar N plus T bar Qn. So that is nothing but T exclusive of Qn here. Okay.
Yes, sir.
So we'll see that. We'll see that with the help of K-map also. But I told you, right? So J and K are tied together. So hence, the T flip flop is called as toggle flip flop. D flip flop is called as data flip flop or delay flip flop. SR flip flop is called as set and reset flip flop. And JK don't have any name. So JK flip flop. It's called as JK flip flop. Okay. So T is equal to 0. Okay. Clock is equal to 1. Okay. And K is equal to 0. So in both, one of the inputs is 0. So what is output here? I'll get. So it is 1, 1. Okay. So G1 is 1. G2 is 1. Clear?
Yes, sir.
Okay. And G3 and G4. So G3 is like 1 into Qn bar whole 1 into Qn bar. So 1 into Qn bar whole bar. So Qn bar whole bar. So I'll get a value of Qn. Okay. So and here 1 into so Qn whole bar. So I'll get a value of 1 into Qn this one. So 1 into Qn whole bar. I'll get a value of Qn bar. Okay. So when T is equal to 0. Okay. So T is equal to 0. So there is no change in the state. So T0. So Q of n plus 1. Q of n and Q of n plus 1. Okay, so irrespective of Q of n plus 1, when T is equal to 0, so it is like Q of n. Yes or no?
Yeah, sir.
Yes, sir.
Okay, and when T is equal to 1, so what happens if T is equal to 1? Okay, we will check the case when T is equal to 1. Is equal to 1, so clock 1, so T1 This is also equal to 1, and clock is 1. Okay, so output of this one. So first we'll see the output of this one. So output of G1. So G1 is equal to, so 1 into this one. So Qn bar whole bar. Qn bar whole bar, that is equal to Qn. Okay, and here G2 is equal to, so 1 into Qn whole bar, that is equal to Qn bar. Okay, this is equal to Qn bar. Okay.
Yes, sir.
Okay,
Yes, sir.
and if I assume like Qn is equal to 0, if I assume the value of Qn is equal to 0, what is the value of Q of n plus 1? This will be equal to 1. What is the value? It is equal to 1. Okay, and if I assume the value of Q of n is, if I assume the value of Q of n is 1, so what is the output I'll get here? And this is 0, and so this is, I'll get a 1 here, and definitely I'll get a 0. The meaning of this is I'm getting a toggle state here. I'm getting a toggle state. So when t is equal to 1, I'm getting q bar of n, q bar of n here. So no.
Yes, sir.
And q of n plus 1. Okay, so 0, don't care, I'm getting a q of n,
Okay.
and 1, don't care, I'm getting a q bar of n. Okay, so this is a truth table of this, and elaborated one. So 0 0 0 1, so 1 0 1 1. Okay, so for 0 0, sorry, yeah, so 0 0 for t is equal to 0, it is the same q of n value. So q of n is 0 and 1. When t is equal to 1, we get a value of toggle of the q of n 1 0. So that will be the truth table. Okay, so that will be the truth table. You can check here. Okay, so there is a truth table. This is the elaborated one. Okay, so there is an elaborated truth table here. Okay, and this is the K map here. So take down that K map and truth table. Clear?
Yes, sir.
So taking that, so simple case, so JK flip flop truth table చూడండి. So simple case ఏంటంటే, so when both are equal ఉన్నప్పుడు చెక్ చేయండి. So when J is equal to 0 and K is equal to 0, ఈ రెండు కేసెస్ చెక్ చేసినా we get the truth table for T flip flop here. So JK are equal. So 0 0 ఉన్నప్పుడు Qn వచ్చింది, so 1 1 ఉన్నప్పుడు Qn bar వచ్చింది. So that is the case here. Yes or no?
Yes, sir.
Okay, so these two values and these two values. So that will give the truth table of T flip-flop here. Okay, so this is the equation for the T flip-flop. Okay, this is the equation for the T flip-flop. Okay, so now we'll see the truth tables of each and every one. Okay, so you have to remember the shorter truth tables. So what is the SR flip-flop truth table? So SR Q of n plus 1, and we'll write the characteristic equation also. Okay, so n plus 1. So x is equal to 0, 0. So what is 0, 0? What is the value here? Q of n plus 1 value?
Q of n.
That is equal to Q of n.
Q of n.
0, 1.
0.
0.
It says 0. So 1, 0.
1.
1.
1.
And 1, 1. It says perpendicular. So that is indeterminate state or forbidden state. So we'll not get this values here. Okay. And the equation of this SR flip-flop. So Q of n plus 1 is equal to
Yes plus
R S plus R
QN.
bar
bar QN. So sometimes you may use QN or QN but this is the case here. Next one is JK flip-flop. So write the equation for JK flip-flop. So this is J and this is K. Okay, and so everything is fine. So everything is okay with J and K are equal, but the only thing is like 1, 1 will get a Q bar Fn. Yes or no?
Yes, sir.
Yes, sir.
So equation is J Q bar Fn plus K bar
QN.
Qn. Okay, so that is the case with JK flip-flop and the equation of this one here. Okay, and the next case is like D flip-flop. So D Q of n plus 1. Zero. So Q of n plus 1 is 0.
0.
Okay, and 1 Q of n plus 1 is 1, and the equation is so Q of n plus 1 is equal to
D.
D. Yeah. So Q of n plus 1 is equal to D. Okay. The same case for T flip-flop. For T flip-flops, we'll be having a T. You don't have the values of this is the truth table of T flip-flop in short, and replace J and K with T. So that is equal to T exclusive of Q of n or Q. Okay, so these are the four kinds of flip-flops that will be available. Okay, next class we'll see the excitation tables of this flip-flop, so which are very important for this one. Okay, so truth tables and excitation tables are very important in any kind of design of sequential circuits. ఈ సీక్వెన్షియల్ సర్క్యూట్స్ డిజైన్ గురించి మాట్లాడుతున్నారంటే సో ట్రూత్ టేబుల్స్ గురించి తెలియాలి, ఎగ్జైటేషన్ టేబుల్స్ గురించి తెలియాలి. సో తర్వాత we can go for the design. Okay, so next class we'll see the excitation tables. and afterwards we'll see the conversion of flip-flops. So we'll be having JK flip-flop to T flip-flop conversion. So T to D flip-flop, SR to JK. So they'll be having many conversions here. So those conversion of flip-flops will be done. Okay. So within 3 or 4 classes, within 2 or 3 classes maximum, by tomorrow or day after tomorrow, we'll finish the conversions part. So with that, so the half of the unit, so the half of the second unit will be done. We'll complete that, right? So listen to this recording. I wanted this long hour because so to understand these concepts. So listen to this recording. The people who are passive, the people who are not listening, just listen to this recording today. This is very important for the next class. So I'll definitely ask you the questions. Definitely do them. So drop your pens and you can leave. And have a nice day.
Thank you, sir.
Yeah.